So why love and math?
Yeah.
And why does love come first?
Yeah.
Right. Well, you know, it's interesting because to me, I want to say in general to me, love and math represent sort of like two pillars of humanity. And we need both of them. Both are essential, and neither of them can be replaced by the other. So it's important to communicate that to me. So and to communicate this need for balance. What I see today more and more is we start thinking more and more that perhaps everything can be measured, calculated, programmed, explained. Everything can be dealt with using mathematics. And I don't believe that to be true. I think that mathematics is very important. It's essential. It is essential. But there is more. There is more. And so what the title communicates is that idea that we need more than mathematics. Love is the essence of life. And love is something that cannot be explained, nor should it be explained. It's something to be experienced, something to be lived. And we actually do live that since the moment we're born, whether we realize it or not. So that's the point. That's what the message that I want to communicate. So there is this thing about infinity, which I think that it's a very important point, which I think is kind of, we miss that, because everything around us, everything we see around us, we perceive around us, is finite. You know, even the number of atoms in an observed universe is finite. And that creates this impression, an illusion that actually everything about our world is finite. And this is one of the reasons why I think mathematics is important, is because mathematics teaches us something about infinity, which transcends space and time and transcends our day-to-day experience. There are other ways to connect to the infinite, through art, literature, poetry, through love. But mathematics perhaps gives the most cerebral way, the most logical way to connect to the infinite. And in today's world, when we are becoming more and more cerebral, when we become more and more rational, and we believe rational arguments more and more over other types of arguments and ideas, that could be a portal, that could be a door for people to see that, to experience that. So it's very interesting that maybe in a different day and age, you would communicate infinity more by love than by math. But in today's world, I feel as though for many of us, the argument with mathematics could be more powerful. Ultimately, though, it is something that I have to discover myself, that each of us has discovered on their own, the infinity of our essence, the infinity of our being. I'm not afraid of these big words, you know. We have to discover ourselves. But there are hints, there are indications that we could use, that reality is actually infinite, and it transcends the immediate experience of space and time. And mathematics is very helpful for this. For somebody very cerebral like myself, it's very helpful. And so, you know, I was just teaching this lecture in my abstract algebra class, and I was talking about infinity. And I recalled a story which was told by a great Zen Buddhist master, T.D. Suzuki, who was one of the first Buddhists who came to America. And he actually talks about Satori, which is this idea of awakening. and he compares Satori to the experience of infinity. And this is something which I like about this story, is that this is something which can be explained mathematically. And his point was, in my interpretation, a mathematician could explain it as follows. There are two types of infinity. There is potential infinity and there is actual infinity. Potential infinity is just the idea that for every number there is a number which is one bigger. So 10, there is 11. A million, there is a million one. Billion, there is a billion one. So it never stops. The number line never stops. So that's one idea. And everybody understands that. But it's still finite, because at each moment you are still at a finite step. You know you can make one more step, but you're still confined in the finite. And what's actual infinity? Actual infinity is the realization that the set of all numbers, 1, 2, 3, 4, and so on, exists as one entity. That kind of the ability to behold all of them at once. That's the idea of actual infinity. And Suzuki illustrated Satori, the moment of awakening, as the moment of realization, of sudden, instantaneous insight that all of them exist all at once, rather than step by step. I think it's something here which is very important. This is a very important element in the story, especially when we are having this conversation today about algorithms and computer programs. Yeah. Because a computer program can never be infinite. A computer program can have, in a computer program, you can always add one more line of code. You can always go to the next step. You can always go to the next step. But you are always within the finite. You're always within the finite, even if you have the potentiality of going an extra step. But I think human nature is far, far transcends that. And as a metaphor of how exactly it transcends, I would use that idea of an infinite set of numbers. If you are a mathematician, you know that the set of infinite numbers, of infinite cardinality, exists. We know that that was a great contribution of the German mathematician Georg Cantor at the end of the 19th century. Modern mathematics is built on this idea. Modern mathematics, we would lose most of the great achievements of modern mathematics if we were to discard Cantorian infinity. So it makes you, being a professional mathematician, you appreciate that idea. You are, it's embedded in you almost. It's imprinted on you. And therefore, you can, that may be a good metaphor for realizing what life is about and realizing the fallacy of these ideas of life being an algorithm, which is what we are hearing today more and more from various quarters. This is a way to see, one of the ways to see the fallacy of these ideas. Of course, there is a connection, but it's not what most people think it is, or that's not what a lot of people think it is. Because I get asked, people see the title of my book, Love and Math, and they ask me, oh, did you discover a mathematical formula for love? And they want to read it because they hope to find a mathematical formula of love. And that's very human, and it's very understandable. We always want this magic pill or a magic formula which would solve everything for us, right? What we don't realize, I think, is how destructive that would actually be if it had been the case that there was a possibility for such a formula. Because let's suppose you found it, and then what? What's the point of living after that, you see? So it's in this uncertainty, in this state of unknown, in the state of infinite potentiality that we find happiness, that we find joy and creativity, all the best love, all the best experiences that we can possibly have. And if you have the answer, So then what? There is this moment of, it's a moment of triumph and a moment of joy when you find the answer, even if it's a mathematical problem. But there's also a moment of sadness in some sense, because it kind of indicates that a certain step, a certain period or certain time period comes to a close, right? So, of course, there is no mathematical formula for love, and this is one of the messages of my book. So mathematics cannot give us an answer, cannot teach us how to love. It cannot tell us how to love. It cannot tell us what love is, but it can give us hints. It can give us indications. It can give us metaphors, useful metaphors. And I think it's important in today's world, especially because we kind of believe in mathematics much more. We believe in science, and in fact, to extreme today, a lot of us, right? So we made it into what Thomas Huxley was hoping for, a church scientific. We have elevated science, which after all was created to confront the dogma of the church, to confront the dogma of religion and this dogmatic thinking, this stale, dogmatic thinking. But unfortunately, today, I think it's been turned around and made into religion by many of our scientists, unfortunately. And so a lot of us find it comforting to believe in something, and they are so happy that they don't believe in God in the sense of organized religion and so on. Well, congratulations. But if you are, let's be consistent and let's not create a church out of science. So, but there is this belief. And so now, what mathematics can help in this case is it can open doors, because for someone who is, a lot of people today are more likely to take something from mathematics than from a work of art. And so I see my job as using those powerful ideas of mathematics, most of which are unfortunately unknown to a lot of people because of the terrible state of our math education and things like that. But to convey those ideas and to help people to see the infinity of life. So in other words, mathematics is not going to solve it for you, but it can help you open the doors so that then you can discover it yourself. But there's one more thing I wanted to say, which is that you mentioned rationality. And so I find it kind of ironic how many people today, and I talk to a lot of people about this these days, they say, I believe in rationality. And it's ironic to me because they don't realize that their belief in rationality is in fact irrational. So in that statement there is a contradiction, because they say, I believe only in rational things. But by saying that, they immediately contradict themselves, because that belief itself in rationality, it cannot be based on any rational argument. And that is a kind of argument similar to Gödel's incompleteness and things like that, which show the self-referential loop. It shows immediately that the limitations of logical thinking, the limitations of rational thinking. You have to start somewhere outside of that. So if you want to believe in rationality, you have to admit that you are subscribing to at least one irrational idea, at least one irrational belief. And I'm not saying it's a bad thing. Of course, rationality is a very powerful, scientific method in general, I would say, is very powerful when it is used to confront dogma. But when it is turned into dogma, it's no better than religion. In some ways, it's worse, because when you do that, you're in denial. You're pretending that you are in denial of religion. You're in denial of dogma, and yet you act as if you were under the spell of dogma. Well, absolutely. Just look at the titles of Ray Kurzweil's books about singularity. Singularity is near. Even the language which is being used is the language of messianic, of end of the world, a religious language, dogmatic language. I mean, and they're not even, he's not, of course, if you ask him, he would probably deny it. But at least that consciously or unconsciously, the language, the words, the manner of approaching the world that I hear betrays that dogmatic thinking. Now, when you say singularity movement, I'm not sure. I think there is some diversity. So in other words, I don't want to lump people together. And one could be, I suppose that the concept itself is not perhaps so well defined. So I don't want to appear as if I am sort of painting everybody with one color. But the more well-known branch, let's just say, people who like Kurzweil, who are well-known sort of prophets of singularity, surely the language, the structure, the approach is undeniably reminiscent of organized religion. This is what I think, consciously or unconsciously, that movement led by these people is starting to look like more and more. Well, there are several layers here, so there's several important points. And one I think which is most important in some sense is why somebody like Kurzweil or other proponents of singularity, transhumanism, strong artificial intelligence, why is it, what is the mechanism, what makes them so caught up in the web of these ideas, in these beliefs that humans are nothing but machines? Because that's what ultimately these ideas betray. The ideas betray that everything, life is an algorithm. A human is ultimately a sequence of zeros and ones. It can be programmed. It's just that we don't have right now enough computational power. But as soon as we do, and his argument is very clever, because if you subscribe to the idea that human life is nothing but an algorithm, so in principle can be calculated, can be programmed, then it's only a matter of computational power before you can create robots, machines, which will completely emulate human beings, right? And then he makes a point that we know that the computing power is growing exponentially. So therefore, in not so distant future, and that's how he's basing his estimates on, in not so distant future, we will get to that point called singularity, right? But the premise here is that life is an algorithm, that human is a machine, you see. And so now there is one issue, which is why somebody like him or others who say that, and there are many people, unfortunately, especially in the Silicon Valley industry, let's just say, in the computing industry, and big companies such as Google and Facebook, etc. Why do so many people believe that? What makes them believe? And second, what can I say as a scientist, as a mathematician, to help others who are not scientists or mathematicians, who are kind of watching this, some in amusement, some in disdain, you know, what can I say to indicate the fallacy of this idea? So these are the two major questions for me. And maybe as far as the second question is that what these ideas betray is ignorance. And as far as the first question is, to me, is what the reason why these ideas are so entrenched now is fear. So it's really an interesting combination of fear and ignorance that drives the leaders of our technological world, many, not all, but many of them who are on record saying these kind of things. That's what I believe drives them, fear and ignorance. Now, as far as ignorance, what is essential to these ideas is the understanding that every organism is the sum of its parts. In other words, a human is just a bag of elementary particles. Some of them actually say that in these words, in so many words. The universe is just a specially arranged collection of elementary particles. It's a direct quote from one of famous physicists. And he would know that that is a complete fabrication. That's what a physicist could say in the times of Descartes, 400 years ago, in the 17th century, or perhaps in the 18th century, perhaps even in the 19th century. Laplace was famous for saying that a supreme intelligence who would know the positions of every particle and their velocities would know the evolution of the universe all the way into the future. But with the advent of quantum mechanics, about 100 years ago, we know that this is, how do I say, I want to make it, to say that it's not true, it would be an understatement. That it is an illusion. It's nothing to, it has nothing to do with the truth. Nothing to do with the truth. We know that the world is uncertain. We know that the world is quantum. We know that there is Heisenberg uncertainty, which is, even in the picture of Laplace, which is a picture of classical mechanics, in order to know the evolution of, even if the world is a collection of elementary particles, to know the evolution, you need to know the positions at a given moment, but also velocities or momenta. But Heisenberg uncertainty principle tells you that you cannot know both at the same time. So how can somebody who thinks of themselves as a scientist, how could they perpetrate this type of ignorant ideas? You know, it's not okay, and I think it's not okay because they're confusing a lot of people. It is okay to love science and to profess your love for science and your love for rationality. That's perfectly fine. But then don't be so selective. If you actually love science, find out what science actually says. Not science of the 19th century, but at least science of the 20th century. So that's the first. Closely related to this is the idea that the brain can be completely described by neural networks. In other words, there are neurons and there are synapses between them. And this is completely mathematically described by this sort of a graph, which is how all consciousness is created. Now, look, yes, it is one way to speak about it. It highlights one aspect of the functioning of the brain. But we know very well that this is not complete. It's not a complete description of the function of the brain. C. elegans, a little worm, which is 1 millimeter long, has 302 neurons. And they have been completely described, and all the synapses between them, by neuroscientists. And neuroscientists themselves, the head of Allen Institute for Neuroscience, Koch, has said, we have no idea how the nervous system of the C. elegans functions, even though we have a complete map of the neurons. 302 neurons, and human brain has hundreds of billions of neurons. So it just shows you the scale of the problem. And look at other issues in neuroscience. The so-called binding problem, that yes, you know, in the brain, for instance, right now I'm looking at you, you know, I can pick up the color of your shirt, I can pick up various features and so on. And we can correlate each of those with particular regions in the brain. But we still don't know, we have no clue how this information comes together to create a particular image. It's called a binding problem. Google it to find out. Now, or the stability problem of vision. Why is it that when I move my head, I still, unlike a camera, which would give a kind of a jerky picture, like a jerky film, I see a stable picture. Obviously, something's happening in the brain. Neuroscientists have no idea how this happens. So this is just a few examples. And so now, my point is that you can only pretend that a human is a machine if you are subscribing to the idea that a human is a bunch of particles, a brain is a bunch of neurons, which contradicts everything we know today about science. It's nothing to do with spirituality, it's nothing to do with love. It is hardcore science, which is, you know, it's not that far away, and especially information so widely available today, Just Google it. That's sort of my advice to singularians and transhumanists. Go Google that. Find out the fallacy of these ideas. Find out how ignorant this is, how much this contradicts reality. And that takes the floor of just from under all these people, all these ideas, right? So that to me is, and yet these people are writing books about the subject, confusing everybody else, pretending that they are experts and who understand, confusing the public, but they don't address these issues. You see, they don't address quantum. And I will tell you, there is this company which was bought by Google 2 years ago, which is called DeepMind. And 2 years ago, Google paid 400 million pounds for this company, more or less $600 million. And I just read recently a profile of the founder of this company, Demis Hassabis, who seems to be a very, sympathetic guy, very genuine, interesting, kind of a cool guy, in The Guardian. But it's incredible to me how these people, how selective they are in the kind of ideas that they are subscribing to and propagating through interviews, through media, and so on. So, for instance, he says the brain is purely computational, and this is sort of like an established fact. He says, I talked to, in one interview, he says, I talked to the top biologists, and the consensus is that the brain has no quantum effects. Well, excuse me, I mean, this is a height of ignorance. This is a height of ignorance because even, just do a very small search and you find even algae are the seaweed are known now, the experiments have shown, are capable of turning on and off quantum coherence between their cells to manage the intake of energy in different situations, in different environments. They start acting as quantum objects and as classical ones. Algae, a little seaweed, okay? There are plenty of works about quantum. Besides, anyone who knows anything about quantum knows how big a role consciousness and the observer plays in measurement in quantum mechanics. This goes back to the great physicists of the 20th century, such as Niels Bohr and Eugene Wigner and John von Neumann, and Werner Heisenberg, all Nobel Prize winners, right? And now for this kid to come and say there is no link between consciousness and quantum, that's just pure and simple ignorance. Up to now, I talked about whether a human brain or human consciousness functions as a computer, in the classical sense, as a Turing machine, let's just say. And the clear answer is no. And I have not even touched upon another, which I find sort of like a fatal argument for that idea. That is Gödel's incompleteness, which we can talk about later. But quantum to me makes a huge hole in this already. And now the next idea is, okay, so maybe not classical computer, but a quantum computer can do it. The problem is that idea is that quantum, by definition, quantum mechanics teaches us that we cannot separate the observer and the observed and the observation. It's all one. A quantum computer, if it is truly quantum, cannot be separated from its environment, just like a human, by the way. And so, in a sense, you can say, well, the whole universe is a quantum computer, but it is kind of an empty statement. It depends on what you mean by quantum computation. If you mean that the whole universe is this sort of a hurricane of quantum processes, in some sense that yes, it is true. And so, but you cannot you cannot localize, you cannot grab this one piece. You cannot separate the human brain as this sort of one fixed entity, which is doing all the work that consciousness is doing, and then upload it onto a quantum computer. So once you said the word quantum computer, in some sense, you are already in the framework, in the realm of quantum. And in the realm of quantum, there is no separation. So therefore, that is a more interesting proposition in some sense. But that proposition, in my opinion, already in making this proposition, you already give up on the idea of creating the separate avatar of a human in the form of a computer, you see. But what's interesting to me is what, in other words, I can go on and list this deficiencies, fallacies. In a sense, and I have to say, at some point I was kind of really curious about it, and I did some investigation. But honestly, it kind of becomes boring at some point. So what I find a much more interesting question is why somebody who's clearly so intelligent, so clever, and has access to a lot of information, consciously chooses to ignore that information. Because, you know, in that same interview, Hasebis is talking about creating a meta-solution for all problems. And what is his meta-solution? Learning algorithms, deep learning algorithms. Well, I'm sorry, I'm a mathematician. I know about deep learning algorithms. You may try to fool others about what this is. But let me tell you, it's not that difficult. It's not even it's not only it's not based on 21st century mathematics. One could argue it's not even based on 20th century mathematics. It's based on 19th century mathematics, which is cleverly adopted, perhaps first half of the 20th century. It's not the Langlands program, let me put it this way, you know. So, and seriously, you believe that everything about life can be explained by that? It's like an 11-year-old who learned trigonometry and is so excited about it. And by the way, it's great that you're excited, but please don't tell me that the world is trigonometry. Because I was like, oh my gosh, a wheel, a circle, it's explained by trigonometry. You know, a triangle, you know, cosine, sine, explained by trigonometry. Oh my gosh, the whole world is explained by trigonometry. What else can it be? Because I've learned it. But don't you think that life is bigger than everything you can ever learn? Has this ever occurred to you? So the answer to this question is one word: hubris. Hubris. That's what it is. Arrogance. Extreme arrogance and self-confidence, which is not based on anything. And what I want to say also is that this is not the first time. This is very human. And in the history of humanity, this has happened many, many times. Of course, you know, sometimes I joke, you know, because I love these people. You know, because they're very clever people and scientists who have these ideas. I sympathize with this exuberance, this irrational exuberance. Speaking about rationality, but then being so irrationally exuberant, I sympathize with this desire to explain everything. I sympathize. I'm a mathematician after all. But it's just, isn't it sort of common sense to have a little humility and not pretend that this one little thing that you've learned and mastered so well is going to explain everything? Has it ever occurred, you know, to you that perhaps there's something else? Right? But the point is that I feel if somebody like that would read, you know, Euripides, he would read Greek myths, you know, they will read about Apollo and Dionysus, for example. They will find out that this is a cycle of life. You have this drive to explain and rationalize, you know, and then that's kind of like left brain kind of taking over, left side, proverbial, I don't mean exactly left brain, but what is meant by, in popular culture by left brain. Proverbial left brain sort of eclipsing everything and taking over. And then, if you're lucky, there's a moment comes when it starts questioning itself and then letting the other side to come back and create a balance between love and math. To me, a film a great work of art which conveys this idea so clearly in the language, which I think people can understand very well today, is Kubrick's 2001: A Space Odyssey. That moment when HAL 9000, the onboard computer, decides to kill everybody because, gee, he says, this mission is too important for me to jeopardize it by having humans around, right? So, and then Dave Bowman is the last one remaining, and he enters the computer and basically goes into that room with a screwdriver and disables the modules of the computer. It's him. It's him fighting his own left brain. It's very clear what's going on. Realizing that this path of rationalizing, measuring, computing, calculating, and explaining and denying the possibility of any other force of life, intuition, insight, inspiration, is a path to suicide. And so at the last moment he stops, he disables that left brain, and he reaches that balance. That's where we are headed, I hope. I'm an optimist. That's where we are headed. But unfortunately, I think a lot of people don't see that. They see themselves as these conquerors who are on a mission to take the humans to the next step of evolution, which to them are so-called spiritual, whatever you want to call it, spiritual intelligent machines. And I want to say to them, guys, don't be so narrow-minded. Don't be so narrow-minded. It's like, William Blake, of course, the famous quote, when the doors of perception are cleansed, everything will appear to man as is, infinite. For man has closed himself in the chinks of his cavern. Don't be so narrow-minded. Don't be so dogmatic. Don't be, open up those chinks of the cavern. Find out what's going on in the world. Find out by the history, for example. Find out realize that what's happening today, this process, has played around for thousands of years. It's a new iteration of that same process. In a way, it's much more dangerous because things are happening much faster today than they used to, with a lot more at stake. So we are indeed finding ourselves in very interesting times, as the Chinese proverb says. Quite a few people today, I have to say, and are sounding an alarm about the development of strong artificial intelligence, such as Elon Musk and Stephen Hawking and Bill Gates and others. So that's great because that attracts attention, more attention to this issue. However, one of the solutions which is being proposed is, well, so the idea is to focus on some kind of an algorithm which would create some kind of a safety environment for artificial intelligence. And I think it's worthwhile to discuss it, but one has to realize the limits of that approach. And the limits come from two sources. One is that the idea that morals can be represented by an algorithm is a false idea. And that is anyone who has any sort of sense of understanding of psychology and philosophy and history can see it right away. But a very simple example is the so-called trolley problem. See, the problem is that people who say that, they're so ignorant because they're so focused on this very narrowly defined field. They start believing that everything is computation. But then what's the point for me to learn anything else? Well, psychologists, philosophers have discussed the trolley problem for decades. And if you just learn a little bit about it, you realize that there is no algorithmic solution to this. There is no algorithmic solution. Any human who is put in a in a position of making a choice between life of this person or that person or this group or that group, there is no way to solve that problem algorithmically. You have to, when a human actually makes that choice, that human is not making it logically. This is well explored issue. I don't want to spend too much time on it. That's just one example. Which, by the way, if we talk, this is relevant to an issue which is much less difficult, much less complicated, but is already, this thing shows up, is the question of self-driving cars, which is a very much, artificial intelligence and so on. One could argue that they were very, very far away and so on. Self-driving cars are more or less happening already, and surely will be happening more and more. And I am stunned how little people who are programming these cars, how little they know about potential conflicts and issues which will kill people, essentially, if they're not addressed. And I'm not saying that self-driving cars should not be used. I'm not saying that. But I think the public has to demand that people who are designing these algorithms are at least aware of the issues and are not looking at the world through the chinks of their cavern, as to use William Blake's words. And I read an article recently from which I found that actually almost no one, there is a professor in California State University who has been working on these issues. And he says in an interview that, as far as he knows, none of the major players are actually having any psychologists on their staff, the ones who are designing all this, the self-driving machines. They're not even aware of these issues. And it's very easy to come up with scenarios where no matter how good your learning algorithm is, there will be situations which will be overlooked. And then you have to have certain contingencies for that, right? So morals, that's just to illustrate that moral issues are not... Look, first of all, we are dealing with moral issues already by using algorithms. This is called law. That's why we have this many volumes of penal code and this and that, where we decide what is legal behavior, what is illegal behavior. It's a very, very complicated system. And in any case, it does not solve everything. It creates a certain framework. To believe that you can actually completely describe human behavior in an algorithmic way is the same fallacy as the idea that a human is nothing but a machine. Okay? So that's the issue which I think is... but even apart from that, the idea that you somehow solve the problem, all the potential dangers coming from the artificial intelligence by designing this sort of safety algorithms. The second issue, first of all, I believe it's impossible, as I have tried to illustrate. But second of all, even if it were possible, what's to stop someone from hacking those rules? So then you spend, enormous resources, make enormous effort to program this moral values into your robot, only to see somebody hack and completely negate all of that. So there has to be something else that will deal with this issue. And so my point is that the only way to deal with it is for humans to realize who we are. And that is what will define our relationship with machines. There's a very important issue which is often overlooked. What do we mean by intelligence? And I think that today, most people mean by that what encapsulates the capacity which encapsulates thinking. And that by itself implicitly denies the possibility that there are certain functions of a human mind which are not controlled by thinking. And that, I think, is a very big issue here. It's almost when I talk to some people, it's almost like people look at this in disbelief. What do you mean there is something which cannot be reached by thinking? You know, so that is one of the cornerstones, I think, of this is where sort of we get off the track. The idea that everything ultimately can be rationalized in the process of our consciousness, in the process of the functioning of the human mind. And things like intuition and instinct and insight, the prevailing view, I believe, in the sort of scientific community, in the community of people who work with artificial intelligence and so on, is that this does not represent a different modality of functioning for the mind, that actually it is completely controlled by thinking. So when they say intelligence, they actually equate it with thinking. Now, if we are talking narrowly about thinking alone, then I suppose there is I don't see anything to prevent a machine, in principle, with the growth of computational power, to reach higher and higher levels of imitating thinking. But I know that thinking is a very small part of the function of the human psyche. This I know. And usually, there are several examples. I mean, is this something that each of us has to discover on their own? Because if whatever I say is, I don't want people to believe me because I was speaking about my own experience. I'm speaking about my own knowledge. And I don't want them to believe me when I say there is much more to human mind than thinking. I want them to discover it by themselves. But I can give some hints. And one of the hints I would like to give is the nature of discovery in mathematical research. Being a mathematician, a professional mathematician, this is what I've been doing all my life, I can speak about this with authority. Anybody can Google me and find out what kind of discoveries I have made in mathematics to see that I am not making this up. And I can share my experience. And this is something which I didn't realize for many years and only recently came to realize, is that actually at the moment of discovery, even in mathematics, which is the most cerebral subject, one would say, right? At the moment of discovery, at the actual moment of discovery, our thinking stops. Something else comes into play. Now, thinking is important. Of course, I have to think and think about it, you know. But then, you know, like Einstein used to say, you think, and then you go for a walk and whistle, and that's when the idea comes to you. It's not by chance. It's not by accident. Sometimes people read the stories and they say, wow, that's weird. What, you know, chance occurrence that somehow the thought didn't come to him when he was thinking, but the thought came when he was whistling. But actually, it's not by chance. That's how it works. I was reading a biography of the great Indian mathematician, Srinivasa Ramanujan, the other day. And explains very clearly, he was famous for making discoveries which nobody could prove. And in fact, he didn't even have a formal math education. And he himself couldn't prove them. So he was this math prodigy, very poor, from poor family in India. And then eventually was discovered by a great English mathematician, G.H. Hardy, and brought to Cambridge, became a fellow of the Trinity College and a member of the Royal Society and so on. But the interesting thing is that when he was asked how he made these discoveries, he said that these discoveries, these magical formulas, which mathematicians have been studying for the last 100 years, came to him in his dreams. The goddess Namagiri would come to him in his dreams and tell him these formulas, which he would then write down when he wakes up. You see? So, that's just an indication. Now, in the same interview of Demis Hassabis, who is the head of DeepMind, I was reading that different offices at his headquarters in London are called after various people. And there is one office, one room, which is called Ramanujan. So I wonder whether Demis Hassabis knows the story of how Ramanujan, by his own account, came to these discoveries, and whether when he finds out, this would change his view that everything about the human mind can be described by a deep learning algorithm. So this to me is a good indication that there is a lot more to human mind than thinking. As far as the thinking, just sort of bare thinking is concerned, I think that yes, machines could imitate, and perhaps pass the Turing test. Turing himself, by the way, made that mistake. If you read his article, I read it a few months ago again, he is very much sort of expressing this point of view that it's all about thinking. He is not allowing for other aspects to come forth in this discussion. And look, you've got Garry Kasparov being beaten by Deep Blue computer. You got a computer by same DeepMind and another group of independently another group of researchers beating a grandmaster in Go. When people look at these achievements, and these are definitely achievements, and I congratulate the scientists who are involved in this research, it's really amazing achievements, absolutely fascinating, and I'm really fascinated by this. But a lot of people don't realize that these algorithms are not operating in the same way in which Kasparov is playing chess or a Go master is playing chess. These algorithms are essentially built on calculating all possible positions. Just whereas Kasparov cuts to the main move right away, using his other capacities, his intuitions, his instinct. Kasparov actually wrote a fascinating article in the New York Review of Books a few years ago, in which he very explicitly explained that. So anybody can find it online and read it. And so, the way these algorithms work is these learning algorithms, which everybody is so excited about. It's a really very simple idea. You have a big sample, hundreds of thousands of positions or photographs. If, for example, recognition software, image recognition software, you have lots of programs. And then you feed this into the algorithm and let it choose a particular algorithm which approximates a human-made choice. So you feed the images in which you say, this is a cat, this is a dog. So the computer knows that this is a cat, this is a dog, and it tries to come up with the most efficient algorithm to decide whether it's a cat or a dog by analyzing the pixels. But I'm sorry, that's not what a 2-month-old child or a 6-month-old child is doing. A 6-month-old child knows very well which one is cat and which is dog, and nobody has fed this child 100,000 pictures, and is doing much better. So at least admit and accept that humans are learning in a different way, and they're using different other capacities. That would be first step to kind of like dispelling those myths, dispelling those false ideas. But yes, certain things can be in certain areas, such as board games or video games, the human capacity for intuition, and perhaps even in some areas of image recognition and so on, for sure. Human capacity for intuition and insight can be compensated by excessive computation. But it doesn't mean that this is the way we function. It doesn't mean that this is a way in which you can reproduce human intelligence. So that's my answer. I can speak for Russia. China I don't know as well, but Russia, I grew up in Russia, in the Soviet Union. So I can speak about that. Russia has a very strong tradition in hard sciences in general, especially theoretical sciences on a kind of theoretical side of the spectrum, namely mathematics, and now more and more computer science. There is in part there is a political reason, historical reason, because during the Soviet times of the Soviet Union, times of socialism, career in humanities or in business was not available to young people. You see, so all the subjects such as philosophy or history or anything really, economics, were controlled and dominated by the Marxist doctrine and Marxism-Leninism, and so you couldn't really have any freedom in pursuing those subjects. And private business was non-existent, no private property and so on. So that pushed a lot of talented youth towards sciences. Now, in sciences, equipment was very poor, so experimental science was kind of out. Also, some important branches of science, such as genetics, were persecuted. Computer science also a little bit, but the government was stimulating all the subjects which were related to defense. So nuclear physics for sure, atomic physics, relate to the bomb. Mathematics was needed for that, so they were supporting fundamental research in mathematics, in theoretical physics, and also in computer science. Even though the computers, when I was a student in the 80s in the Soviet Union, we still had computers we had were replicas of IBM machines from the 60s, from 20 years earlier, which I imagine maybe there was design was stolen perhaps, or some kind of espionage, I don't know what, but there's these huge machines when there were already laptops, there were already personal computers, not laptops, but personal computers in the United States. So it was lagging behind. Now, of course, it doesn't lag behind anymore because of the global connections. But so I would say that one of the answers is a tradition in computer science. There are very strong computer scientists in the strong school. In a lot of people come from that tradition, but it doesn't still. And I think in China probably similar. In fact, you constantly hear the stories about Russian hackers, Chinese hackers, and this and that. So I think there is this tradition. And people who have these ideas of transhumanism, strong artificial intelligence, singularity, and so on, they usually come from that field. They come from the field of computer science, because for the reasons we have discussed, it's natural, it's very human. Even though they deny their own humanity, what they're doing is actually very human, because they get so excited about the stuff they learn, and then they start believing that that's all there is. You see, so that's one of the reasons. So, in other words, people in other professions, in other sciences, if you look at biologists, for example, they'll be much less likely to subscribe to these ideas, right? But for mathematicians and computer scientists, that's quite common. It still doesn't explain why so many of these brilliant, bright people, and I think Kurzweil, for example, I think is a brilliant man. He's really very bright, very smart. And so is Demis Hassabis, that I mentioned earlier. But it still doesn't answer the question why they have these blind spots, in my view. Why there are these sort of glaring omissions in their worldview. So they conveniently avoid speaking about Gödel's incompleteness, about quantum mechanics, about advances in neuroscience and psychology, which show clearly and unambiguously how much more sophisticated the workings of the human mind are than what they are leading us to believe. So why there is this blind spot? And I think this is really the heart of the issue. And it's global. It's a global phenomenon because it is about humanity. It's not about a specific country or society. And it is about knowing who we are. It's about knowing what it means to be human. And I'm sorry to say, but I think that trying to build these machines on which to upload ourselves is a way to escape from ourselves. It's one's way to escape from oneself, to escape from one's pain. And that is something which I don't say lightly, because it is something which I have discovered about myself, and I feel that it's a universal sort of it's a universal mechanism, which is in this era of computers and social networks and so on, is taken a very particularly troubling form, that escapism from reality by means of denying one's own humanity. So that's what I think is what is uniting these people from different countries that you mentioned, through no fault of their own, in some sense. I mean, we are all, it is very human. It is very human to want to escape pain. But we've talked about this earlier. You've got Dmitry Itskov, who is one of the extreme cases, proponent of this Avatar project, Initiative 2045, where he is perhaps going further than others in terms of already constructing, not just talking about constructing sort of avatars, sort of the shell which he believes he will take when he's uploaded to this cloud, to this network. First of all, this already shows a complete ignorance of what the human body really is. The human body is not static. It's constantly moving. It's constantly rejuvenating itself. The cells are constantly dying and being reborn. It's like a whirlwind in a pool. It's not something you can grab and make a copy of. It is a complete misunderstanding of this idea. So he suddenly is making this thing. Here is my body. But what struck me when I investigated this, and I have spoken about it, as you know, what really struck me is the facial features of this avatar, which he has created in his own likeness. Yeah. It's very, very sad. It's the saddest robot you'll ever see. And it's paradoxical, because on the one hand, he wants to seduce everybody with these ideas and attract funding and support. And then he presents this human-sized robot, which kind of looks like him. He looks super depressed. And that is almost like, that here is a testimony to the unconscious, to the power of the unconscious. So on the surface of it, he is this very enthusiastic guy about Avatar Project Sun, but he cannot suppress his unconscious, which expresses itself in the way it looks. And it's very telling. So even if he makes this, he cannot pretend. In the end, you cannot pretend. All this, you cannot run away from yourself. You cannot run away from yourself. And that's the catch, that's catch 22. Because the point is, each of us, Dmitry Itskov and Ray Kurzweil and so on, and I love these people. I think they're really wonderful, good people, fundamentally good people. They're not trying to do anything evil or anything like this. They have to come to terms with these issues. They have to come to terms with their inner world, as it were. And nobody can force them. So I have gone through this process. I have worked on myself, and I was able to see things which I hadn't been able to see not that long ago. So it's very powerful, and I see people around me, some who do this work and some who don't. I know that I cannot force anybody. Nobody can force. It's like in another film of Kubrick, Clockwork Orange. They used to put Alex and open his eyes and force him to watch these films. It doesn't work. It doesn't work. You have to do it yourself. And you will do, and they will do it when they're ready for it. When they're ready for it. But so for me, it's not to try to convince them that they should work on this. You know, it's like I cannot tie, you know, Dmitry Itskov to a chair and make him remember his childhood and perhaps find out about what really happened, find out about his traumas, which are guiding him in these endeavors. And which, again, by the way, nothing wrong with it. It's human. It's perfectly human. So I know I cannot do that. What can I do? I can share my experience, which I do, as you know, in my public speeches and interviews. But also, I think it's my duty to expose that to other people who are being fooled, frankly, by these experts, the self-appointed experts and prophets of singularity and transhumanism. Because people are not aware. Part of it has to do with our terrible math education and science education in general, but especially math education. People are afraid of mathematics, they're afraid of computer science, they're afraid of coding. And the flip side of that is that then they start worshiping it. They are ascribing the supernatural powers to mathematics and to mathematicians. So when they hear somebody like Kurzweil, who is clearly a distinguished engineer and scientist and inventor, or Demis Hassabis, people tend to believe that simply because of their authority in those matters. Well, now I'm a mathematician, and my job is to explain that the reason why they're selling us these stories, is not their expertise in science, computer science, and mathematics. In fact, they are going against that expertise. They are bluntly incapable of seeing obvious things which contradict their theories, right? So what's driving them, in fact, is their humanity, is their psychology, is their unconscious, whatever you want to call it. And I think that this is what we today have to realize very, very clearly, because the technology is intruding on us. I mean, I was just reading this article. 3/4 of young people under 25, 3/4 of young people under 25 say that the first thing they do when they wake up is they reach out for their smartphone. Although 61% say that they believe they use their smartphones less than other people. So, of course, I'm not doing it, but then I'm doing it, right? So, technology is invading our lives. And it becomes, so then when I say, why, Professor, are you saying that life is not an algorithm? Because my life now starts looking like an algorithm, because I'm constantly doing this. I am becoming an extension of my iPhone, not the other way around, you see. So that's why I think it's very important to see the fallacies of this idea, the fallacy of these ideas. But to see that, it's also important to see the source. Why somebody like Kurzweil, somebody like Itskov, and so on, why are they so enamored with this idea? Where does it come from? What is the source? And I think when people will see it, they will pause and they say, it's not that they know something I don't know. They don't know something about themselves, which makes them propagate these ideas and push it on us. We will not allow this. This already happened in some sense. It's like, there's no question that this Silicon Valley, the men of Silicon Valley, I call them, they are the new elite. There are some women too, but not enough. So in fact, I think we do them a lot of good to include more women. But for now, it's mostly men. And look at these people. I mean, look, with love and respect. But come on, look at this. Just this one thing comes to mind. Mark Anderson, one of the top investors of Silicon Valley. The debacle with his tweets about India and about Facebook's offering free internet to India, but with a caveat that they would be controlling which websites would be accessible through that internet. And India to their credit. The government refusing that offer. And then Andreessen, who is a prolific Twitterer, goes and tweets that, oh, these people are so stupid not to do it. They see how that's what they criticized colonialism, and now they're criticizing Facebook. You see, so he actually makes the link himself. So that's the height of hubris. That's the height of ignorance, the height of arrogance. But in a sense, it's helping us because he then gives away the secret that everybody knows, that yes, it is colonialism. That is a new form of colonialism. And we are being colonized, not in India, but everywhere in the world. We are being colonized by these technology companies, which operate with very little oversight, which have tremendous power, which have time and again have colluded with the government. There are exceptions, of course, but unfortunately it's more of a becoming more and more a default. And again, you know, I have no doubt in personal integrity of any of the founders. But let me give you just one example. You know, when Google was founded, what was their motto? What was their slogan? Don't do evil. Well, guess what? A year ago, they changed the name of the company to Alphabet, and they changed their slogan. It now is, do the right thing. To which I'd like to ask, the right thing for whom? The right thing for whom? So it's not anymore, don't do evil. You know, when Google acquired DeepMind 2 years ago, they promised the creation of an ethics board to tackle questions of artificial intelligence. 2 years later, there is no information about this ethics board. In fact, I just today, just to be sure, I Googled it again. I Googled Google Ethics Board. There is no information. The latest is that Demis Hassabis was saying that he wanted to create it. 2 years later, after they having promised. Now, I give him personally a lot of credit for, in fact, it appears that it was his personal initiative to insist on creating such a body when the company was acquired by Google. So I have no doubt in his good intentions. Nor do I have any doubts in personal, good intentions of other founders, of other companies I have mentioned. However, it's very telling that 2 years later, there's no board, there's no transparency, there's no information, there's no oversight. So what it starts to look like more and more is, as a great author, Paulo Coelho said, the Nobel Prize winner, boys with toys, boys with toys, but these are dangerous toys. It's like a child in the supermarket who finds a handgun in his mother's purse without safety on it, you see. So that's where we are. And unfortunately, I don't hear so much discussion of this. I don't hear so many people asking why there is not enough oversight. So yes, it is a new elite. And I'm not saying it's a bad thing, because obviously, the men in our government haven't done much better, but at least they're elected. And you can talk about the flaws, the obvious, glaring flaws of the electoral process, but at least there is an electoral process. In the case of companies like Google and Facebook, we have multinational, huge multinational corporations which are controlling bigger and bigger parts of our lives, which are themselves controlled by a very small number of people who are not beholden to anybody except their shareholders. Now, if somebody thinks that this is not a recipe for disaster, I think they should think again. Yeah, very serious issue. I'm very pleased to have this opportunity to speak to the Turkish audience. I have visited Turkey several times, and it's one of my favorite countries in the world. I really enjoy the culture, the history, the food, the people, famous Turkish hospitality, and really had some amazing times in, especially in Istanbul, but in other places as well. And I think Turkey is one of the most important countries in the world today, because Turkey is right in the middle of all the conflicts, sort of all the axes of power, of conflicts, go through Turkey today. And that means it's not so easy for Turkish people, but it puts a lot of responsibility on Turkey, I think, in the world. It has a lot of, I think Turkey will play a bigger and bigger role in the next few decades. And so I think my sense from visiting Turkey, and I was there just a few months ago, is that a lot of people are aware of this. And that I find very heartening, especially young people, so full of energy, so full of life, so inquisitive, so curious about everything, and looking for new ideas. This is what we need. We need new ideas. We should not allow dogmas and prejudice and sectarian separation, especially, to dominate our lives the way they have been dominating us for so long. We cannot afford that anymore. And I think that I feel like Turkish people are sort of like the avant-garde, kind of like in the front rows of that change that we desperately need today in our world to survive. So I hope you enjoy this interview, and I look forward to the continuation of the dialogue.